Hello everyone, welcome back to my channel Be an Architect. I am Anubhav Giri, and on this channel we don't memorize Swift. We visualize the Swift runtime. Because once you understand what Swift is doing behind the scenes, many language features suddenly become simple. Today we are going to understand one of the most misunderstood topics in Swift, how closures capture variables. If you ever heard someone say closures capture variables and thought, okay, but what does that mean? Then this video is for you. By the end of the video, you will understand why closures print the latest value, what a capture context actually is, why capture lists change the behavior completely, and when you should use each approach in real applications. So instead of memorizing another Swift rule, let's visualize the runtime. We are going to learn this in 3 steps. First, we will write a very simple closure. Then we will switch to a runtime visualization that shows everything Xcode cannot. And we will literally watch Swift create the closure object, build the capture context, and store the reference. After that, we will modify the code using a capture list and compare both runtimes side by side. Once you see both visualizations, you will never have to memorize this topic again. So let's jump onto the Xcode. So here I am defining a value and assigning 10 into it, and then in the closure scope I am printing it. Then I am changing the value to 20 and run the closure. Notice inside the closure we simply print value. After the closure is created, we change the variable to 20, and then finally we execute the closure. What do you think this will print? So let's run the code. So most developers answer 10 because the closure was created when the value was 10, but output is 20. Interesting, right? Why? Let's visualize the runtime. So today we are going to visualize exactly why this happens. Instead of looking at Swift code, let's look inside the memory. Initially, only one thing exists, that is value 10, and that is lives on the stack. The heap is completely empty. Nothing special has happened yet. Now Swift reaches the closure, but notice nothing has been allocated yet. The moment Swift creates the closure, it allocates a brand new object on the heap. You can see in the right hand side, this is the closure object. One important thing, closures are reference type, and that's why they live on heap. This we already covered in our previous videos. Inside the closure object, Swift stores the executable code. Think of this as the instructions that will run later when we call the closure. So far, nothing surprising. But a closure object contains something else, capture context. This is where Swift stores everything the closure needs from the outside its own scope. This is the part that most developers hear about but never actually see. Now look carefully, Swift doesn't copy the value into closure object. Instead, it stores something much more interesting, a reference. That reference points back to the original variable on the stack. Notice what Swift captured, not the number, not the value, but the relationship. That's an extremely important distinction. Now Swift reaches to 20. Notice something beautiful. The closure object didn't change, capture context didn't change, reference didn't change, only one thing changed, and that is the variable stored on the stack. Because the reference still points to the same variable, the closure will now read 20, not 10, and let's prove it. We executed closure and Swift gives us our output 20. Now the output makes complete sense. The closure didn't remember 10, it remembered where the variable lives, That's why it always reads the latest value. Now let's jump on to another example. Now remember the same visualization we used for the example 1. So now you will see, instead of capturing the reference, this closer is capturing a value. So initially the value is 10, but when the value changes to 20, still the output remains same, that is 10. And the reason is closer is capturing a copy instead of reference, and due to that the output remains 10. So we can understand, when the closer executes, it no longer reads the stack. It simply reads the copied value instead of its capture context. That's why the output becomes 10. So let's summarize everything we learned today. By default, closers do not copy variables. They store a reference inside the capture context. That reference always points back to the original variables, which means when the variable changes, the closer automatically reads the latest value. Capture lists behave differently. Instead of storing a reference, they store a copy. That copy never changes even if the original variables does. Once you understand this mental model, closers become much easier to reason about. Especially when working with asynchronous code, networking, animation and swift concurrency, if this visualization helped you understand closers in a new way, consider subscribing to this channel. In the next episode of Understand iOS Memory series, we will continue exploring what's really happening behind the scenes inside the Swift runtime. Until then, keep learning, keep building, and as always, be an architect. Thank you.